What is completing the square? By Andrea Steineff.
Completing the square is a couple of simple little steps to create an expression that can be easily factored. Completing the square works because all we are actually doing is reconfiguring our expression to create a geometrically perfect square.
First, let's recall what factoring is, besides being one of the F words of algebra. Factoring can be done quite easily if we have an understanding of perfect squares. Remember, factoring is the process of breaking up expressions into bits that are multiplied together. We do this to see what the expressions are made of and to see what is common with other expressions. Perfect squares are numbers that are the easiest to factor. A perfect square is created by a number that is multiplied by itself. Here is a list of some perfect squares. The perfect squares are the numbers that are darkened in the middle. If you notice, each one is created by multiplying a number by itself to create that new number. Let's think of this in terms of geometry. If you have a square with sides of 3, the area of the square would be 3 times 3, which equals 9. So 9 is a perfect square because it is made up of 3 times itself. As well, you should notice 9 is on our list of perfect squares. In contrast, if we made a figure that has sides of 4 and 3, we would not have a square, nor would our area be a perfect square, because the sides are not the same number. The area of this figure is 12. The side of 4 times the side of 3, and our shape is not a square, it is now a rectangle. And you'll notice from our list of perfect squares that 12 does not appear, because it is not a perfect square. Factoring perfect squares is the easiest factoring we can do, but can we factor an expression that is not perfect? Yes, we can. And this is where the process called completing the square comes in. When we're thinking about things geometrically, we want to reconfigure our shape so it is a perfect square with the same length sides on either side. So to explore this concept further, we are going to start working with variables. If we are given the expression x squared plus 6x, this can be represented using geometric figures as this red box represents our x squared. It has equal sides of x times x, which gives us an area of x squared. And then this blue shape gives us the 6x. The height is still the same, so this height is x, but the width now is 6, so this is 6x. Okay, so now we know what x squared plus 6x looks like as a figure, and it's a rectangle. And we know that if we can shape it into a square, then it's going to be easily factorable, because the area will be a perfect square. And this is how we do it. We take this 6x, and we're going to divide it in half. So we are dividing this box in half. And now this whole area used to be 6, but if it's divided in half, now each side is worth 3. And the area of each box would be 3 times the side of x. Now you can see I've separated my blue rectangle, which represented 6x, divided it in 2, and I just added that, moved the top, one of those rectangles to the top of my square, my x squared square. So I still have 3 times x as the area for this rectangle and for this, and added together they give me my original 6x. And then I still have x times h, which is x squared. So my expression's the same, I've just reconfigured it. Now what we're missing to finish this square is this little bit here. Well, this side of this square is 3, because these are the same size. And the side of this other, the length of the other remaining side has to be 3. So the area of this little square that's missing is 9. Now going back to our equation, our original x squared plus 6x, we are just going to add this 9. This missing little piece that makes our new figure a square. We're going to add 9 to our equation. And now we have created a perfect square trinomial which we can factor. Plugging our trinomial that we created, x squared plus 6x plus 9, into the formula for perfect square trinomials, we get an answer of x plus 3 in brackets squared. And we have easily factored our expression. So how did we do that? The formula for an expression in x squared plus bx form, for completing the square, you take the middle term b and divide it by 2 and square it. This gives you the number you add to your original expression to make it a perfect square. It is also the area of the missing corner of your figure as you reconfigure it into a square. This process of completing the square creates a perfect square, which can always be factored, making that F word of algebra just a little more manageable.